take it away.
Great. Thanks so much, Tom. Okay, so today we are going to talk about who we are, what the situation with the client was that led to this project coming into existence, how we handled our solution in two different parts. The first being how we compile our data, and the second being how we use that data to create dashboards and web maps, the process for updating those dashboards and web maps, and finally, how the client felt about our results. As a hint, they're pretty into it. So our information is in the agenda, but just a little bit of information about me and Gillian. I have about 5 years of experience with GIS mapping, data management, and dashboarding. My primary focus is on quality control and data analytics. And a fun thing about me is in my spare time, I provide GIS services to a volunteer soil organization within the state of Ohio. And Gillian has 20 years of experience with geographic modeling, spatial analysis, cartography, and mobile app development, utilizing dashboards through things like Esri, Stack, and Power BI to support project teams. So Brown and Caldwell supports a township wastewater utility in the state of Pennsylvania with their condition assessment program. Over several years, many small databases from individual inspection events have been created and not necessarily unified into accessible formats. This data was spread across many file types and many different files. In order to better provide insights into their infrastructure and facilitate easier decision-making, we wanted them to be able to visualize and interact with all this data without the struggles of managing these disparate file types and locations. To that end, we created dashboards and web maps providing this access. So showing what matters and avoiding all of the nuance and intricacy of behind the scenes data storage. So this is what the client's current data visualization system looks like. It is nothing. We started by identifying these data stores. For example, data might be delivered through email, cloud sharing services like OneDrive, or even on physical hard drives. Then we determined the most appropriate storage software for these different data types. These data serve different purposes for different teams and project tasks. So the quote unquote best place to store information depends on what the data is being used for. This means for ease of access, sometimes the best approach is to take a data set and place its individual components, tabular data versus visual media, and store them in different places. There are storage and file sharing struggles with the size of these data sets, usually with their associated video and photographic media, and also with the software licensing and training costs to most effectively manage these data, which may be prohibitive for a smaller team to adopt in the same way that a larger consulting company can. So we wanted to empower this client to access and mine their data to better manage the condition of their infrastructure. So some of the many locations that data was being stored included spreadsheets or tables to summarize key metrics or answering questions that came up specifically. Another place is on-demand map figures. As an example, we recently generated figures to provide spatial context for an upcoming inspection event. The client only knew that they wanted to locate manholes near right-of-ways and inspect those. So we helped them identify these based on a buffered selection from road center lines and created maps to help them plan their project approach. We're more than happy to provide these services, but think it would be even better to help the client be more proactive using Esri's web mapping tools. For example, in addition to creating these sorts of deliverables, these analyses, buffers, or selections can be performed in a web map during a meeting by the team or with the help of Brown and Caldwell to begin preliminary planning instead of having to wait days for a deliverable to come through. Another location for the data that is coming in is visual media being stored in folders. The struggles with these are manifold. Large folder tree structures where individual media is stored by manhole within a folder for a given inspection date in a different folder, within a regions folder, and so on and so forth. It can be hard to navigate those folder structures. Another issue is the resources required to locally store and view this much data can slow a computer down to a crawl, which nobody has time for. It gets very frustrating to figure out the location of a single video in a sea of data. So what Brown and Caldwell chose to do is store the tabular data in the Innovyze InfoAsset Manager database and store the visual data in cloud servers. Brown and Caldwell alternately uses two cloud storage services, those being Pioneer Sewer AI and T4. The interface shown here is the Pioneer Sewer AI service. And here the visual media is stored in the cloud, accessible through a web interface, and that moves these large files off of local machines, removes the latency of streaming these large videos from local machines, has optimized keyword search functions to quickly locate inspections that you might be looking for, and essentially removes the concern of data corruption that could arise when sending hard drives back and forth between offices. As mentioned, the best place to store different types of data is really dependent on the situation. InfoAsset Manager is a great software tool that has many, many positives, including the fact that the software allows us to import data from any CCTV and survey software into this centralized database. It is highly customizable. It is version controlled. It is far more secure than spreadsheets. And it is NASCO approved for storing pipeline condition assessment data. So this is kind of a before snapshot of what the tabular data looks like in the InfoAsset Manager software. Each of the columns that we see in this screenshot have essential information about the condition of the pipes that were inspected. And the software is tracking version history and editor status. That's what the different cell fill colors are representing. These functions ensure that it is always clear who has done what, when, where, and why in the data, as long as the database is structured correctly. What's more, as much critical data as we can see from this snapshot, there are dozens of additional default columns and user customizable columns that can be set to meet the varied reporting or compliance needs for any given use case. But there are also downsides, like getting a quick geospatial summary of data for a single pipe or maybe groups of pipes in one area is harder to do than one might hope. Or the ease of how one could duplicate a column of information if one is not aware that a column already exists when you have nearly 300 default columns that you're looking at. And that doesn't even get into the additional tables for representing defect codes from an individual inspection. The fact that the Innovyze InfoAsset Manager interface is very information dense, containing a lot of columns that may never get populated, that makes things a little harder to cruise through the data, and it's not necessarily the most intuitive or smoothest experience unless you put in preliminary work to hide the columns that aren't relevant. Also, its interface, it does have a map component, but it doesn't facilitate pop-ups into the tabular data very easily. If you want to know information about a specific pipe's inspections while also viewing where in the system that pipe sits, there are several steps that need to be taken to display only the information that you care to see. So the software, fantastic. However, it requires purchase and ongoing licensing to use. And as a database management software, there's a potential learning curve or training required, especially in the use of SQL in order to use the software efficiently. These issues, and or similar ones, are a struggle for many stakeholders and project managers who want summaries of their information without needing to coordinate with multiple team members or know the intricacies of use for all these different softwares. Brown and Caldwell has a wide network of expertise and communities of practice across the country, which maximize efficiency and provide best practices in solving the problems we face. And we wanted to bring some of that empowerment to this client as well. So that was the background info. Our idea of how to fix the problems were considered with input from what the client needed. And once we had those things laid out, we could set our goals for the dashboard. Those things were displaying inspection metrics and visuals together in a linked manner, accessing all of the data in tabular format and the visual media through one interface, taking advantage of the existing data quality structure provided by InfoAsset Manager and minimizing the need for specialized tool training, and allowing for insight collection through web mapping and dashboard functions. So that facilitates insight collection for the client through these functions. We might be seeing an area that have pipes with many defects. We can then take the next step and analyze why that is. So in order to compile the data, we took a couple of different steps. The first thing we did was create a column within the Innovyze InfoAsset Manager database to join all of the hyperlinks connected to the inspection media on the cloud servers into the tabular data. Once we did that, then we would check the commit history and pull any database changes within InfoAsset Manager before we make an update to ensure that the data is current and precise. Once all of those things are linked, we can export everything from InfoAsset Manager as a geodatabase and then incorporate that data into the web maps and dashboards. And Gillian is going to explain the next steps that we'll be taking once we have the tabular data in that geodatabase format.
So next slide. Perfect. So yes, as Rachel has presented, now everything is in a geodatabase format, so it's ready for any Esri application. But just before we discuss that part, I'm just going to say, after it's been published, I'm just going to discuss the update process while we're here. So to make things simple, what we do is we retain past versions of the data so that we can copy and paste it, and then we can change the source referencing. This makes it an iterable process and makes it really fast and efficient. And to make sure that the layers are first properly symbolized and have the correct pop-up windows. We do this here instead of once it's published, because then when we actually update the data, we don't have to redo the pop-up windows. Again, trying to make everything really efficient and an iterative process. And it's important to remember that we utilize the hosted layer IDs so that the new data export can seamlessly overwrite the previous data that's been published. And of course, we created an SOP so that in case one of our GIS analysts who normally does this is sick or out, that any GIS analyst can just pick up and be able to do the same process. Again, it's iterative, it makes it quick and efficient and easy for anyone to understand. So next slide. So here we go. Here's the dashboard. As you can see in the top left, it's just like the skeleton of the dashboard. So I'll go over each little section that we discussed with the client and that we decided together to put on the dashboard. And just to mention, we blurred out some of the data in the previous slides, and we might be blurring out some more just to keep it a little less easy for you to know the data. But so let's start with the left-hand side. Yeah, these are the filters. So I don't know how many of you know about Esri dashboards, but filters are a great way to see your data, to get specific data really fast and to get only the data that we care about. And it's also, you can filter and have an action where your map also filters based on what you have filtered for. And sometimes they're just needed to go over your data. So here we have a filter on the date range, and this was only connected to the CCTV survey data. It wasn't connected to the other data. But all the other filters are connected to the pipe data. So we have two different types of filters going on depending on which type of data you want to filter. But again, this is just for this client, and you can do any sort of filter you want, and it's a great way to see your data. Okay, yeah, this is blurred out. So these are the details pane. And again, these get filtered based on the date range that we picked for the CCTV survey. And this is the pop-up window that comes up basically. Instead of having it small and in your web map, it's a big details pane. So we have one for the CCTV survey and one for the defects, so that and they're on top of each other, and we can just go back and forth between each of them to see our data. And this is better than what Rachel talked about in the like 300 fields in InfoAsset Manager. This in the pop-up window, you can decide which fields you want to turn on and turn off, and this is what the details tab can show you. And then at the top, we put in a simple last updated panel. We thought this was important, and the client really liked this too, so that when they grab screenshots of their web map and of the dashboard in general, they knew if the data was up to date or not. They also knew if the dashboard was up to date. So sometimes they ask for a change. We changed the last updated date for the dashboard and for the data. This is another way to kind of track, you know, what has changed over time. And finally, we have the indicator section. This part's really important for them because it's a clear, concise way to show their data. What we decided is actually the two middle sections, the pipe count and the miles of pipe. Those would be the only two that actually do filter. The ones on the sides, the CCTV survey count, the miles surveyed, the pipes with defects, and the pipes inspected are always static. This is what we discussed with the client and it's what they wanted. But again, those can change depending on what your client wants also. So we're just going to quickly go through. So the top is a small window. This is showing everything before we decide what we want to filter by. So as you can see in the next slide, we are filtering by date. And you can see how nothing changes except for the details tab and the map. So you can see that, you know, between January and June 2017, the CCTV, this is just again the CCTV survey. You can see where they surveyed their data. And this is, again, a request of the client. It's a great visual, like you couldn't see that in InfoAsset Manager. And it's a really quick way to say, oh, where were we? What did we do? And what do we still need to do? And the next one is showing what updates based on your pipe material. So the vitrified clay pipe, you can see how 20% of the pipe count, or 703 to be exact, or 20% of the total mileage of pipe is changing, is updates. And again, this is only the two middle indicators, not the side indicators, are updated based on what you choose for your pipe count. For your pipe material. And finally, you can also change the dashboard indicators based on zooming in and zooming out of your web map itself. So here we zoomed into an area and you can see that 3% of the pipes mileage in this area were surveyed, and the details tab just to the left, there's 76 defects on these pipes in particular in this map. So again, this makes it really easy for in a conference call or a quick screenshot to filter out your data and see where you are and answer questions really fast and easy, instead of having to say, oh, you know, let's scroll through all of our columns in the InfoAsset Manager, or what pipe specifically were we looking for, and what is the T4, the Sewer AI link to that pipe, and then you have to copy and paste pipe IDs, and it's just very difficult. And one thing we didn't mention, or I'm mentioning now, is that, again, this was just for a small group of people and a client. And we have done this for other clients as well, use the InfoAsset Manager and the update and provided dashboards for them. And you can share this through your groups setup. So if you just wanted to do it internally, that's great. But we've been sharing this externally through our ArcGIS Online and invited other organizations so that they can share it with their organization also. And again, it doesn't have to just be for, you know, your GIS people. You can, include your project managers or financial people, if, if they need to see the dashboards too. And again, it depends what indicators you want. You can see on these ones, we've included graphs, and you can also filter your map and your indicators by the graphs. It just depends on what your client wants and asks for, and access. Who needs and wants access to these dashboards to make their work easier?
Okay, so what was the reception of these deliverables? The client was pretty pleased with the dashboards and their ability to visualize the data more quickly and to help them more effectively support their needs. And we're really happy to be a part of that process with them. So that's what we have currently for the dashboard, but there are future areas of opportunity for this whole condition assessment process. One of which, as has been mentioned earlier today, is in machine learning. In addition to serving as a cloud server for visual media, companies like Pioneer are implementing machine learning algorithms to perform video coding. These algorithms could be used for either first pass review, which would reduce man hours and limit manual reviews only to those inspections that both the survey team and the algorithm have identified as having defects. It's also possible that for some use cases or clients, machine learning could even be used as a back check or a full review process to ensure data quality and precision. Another opportunity is using these cloud services for both visual media and tabular data storage. Brown and Caldwell is also testing cases where infrastructure data is entirely getting hosted to the cloud and linked to service accounts for both the consulting team and the client to facilitate immediate data access and also tabular co-editing. So that's kind of everything that we have. I wanted to thank you for your time. And if there are any questions, we'll be hanging around and answering them. If there's anything that you have questions about in the future, here are our email addresses, and I hope that you have a good evening.
Awesome. Great presentation, ladies.